Hello everyone. I made this video to help you review the exponential growth and decay. On this video, we will be reviewing the definition of growth and decay function and solving word problems involving exponential growth and decay part 2. Alright? First thing first, we want to talk about the exponential growth and decay function. Actually, these two functions derived from y equal to a times b raised to x power. Alright? So, when you look at this function, you have to know that b need to be greater than 0. b need to be greater than 0. And when we talk about growth and decay function, b can be either equal to 1 plus r or 1 minus r. So that these two, 1 plus r or 1 minus r, symbolize b. So, growth function we have 1 y equal to, we just bring down the a, times 1 plus r raised to t. T is the same as x, which is the variable that we are going to input the value in. However, since we're dealing with time, so we exchange x with t. The decay function, we have y equal to a times 1 minus r raised to t power. So let's talk about these variables. A is our initial value. Because when you have time equal to 0, everything raised to 0 is equal to 1. 1 times a is a. So a is your starting value. So next thing is r. R is the growth or decay rate. Decay rate. Here, one thing you need to remember, it has to be in decimal form. A lot of time, the problem gives you the rate in percent form. You always need to change or convert that into decimal form when you are using either the growth or decay function. Another thing is r also has to be greater than 0. Okay? It's kind of clear here. Since you know that b has to be greater than 0, that means everything here, you have to be greater than 0. 1 is a positive number. R cannot be a negative number. Well, this will make this side equal to negative. Same thing here. R cannot be negative, or else b will be negative too. So r has to be greater than 0. Next thing, time. T is the time, okay? The time interval. What I want to stress here is that time can be in different units, depend on different problems. It could be in seconds, it could be in minutes, hours, day, weeks, months, years. Depend on problems, you need to identify what is the unit for time. Sometimes you may need to convert the unit from one unit to the other unit. For example, hour to day. Okay? Next, y is your final value. And that is all we need to know about the exponential growth and decay function. We are moving on to the examples. So this is the example that we have in the slides. Example number 5, solving for R. Now here is solving for the growth rate. So the problem is the population of a town started with 12,500 residents and increased by 500 residents after 2 years. Determine by what percent to the nearest percent did the population of the town increase each year in these 2 years. Whenever you are working with a word problem, you always need to find the key information, okay? Either by underline, circling, highlighting, whatever you want. Find out those key informations. Right now, I will be using a red pen to underline the key information. So first, it says the town started with a population of 12,500 residents. That means our initial value is A equal to 12,500. Now it said increased by 500 residents after 2 years. So that gives us two information. First, it tells us that at the end of 2 years, the population is increased by 500. That gives us the final value. The final value is y equal to 12,500 plus 500, which is equal to 13,000. All right. Another thing that they tell you is the time. Here, everything is in year, so t is equal to 2. And what we are looking for is that determine the percent. What percent did the population of the town increase each year in these 2 years? It's asking for the rate. And specifically, it's asking for the growth rate. Okay? Growth rate. So we need to set up a exponential growth function. Y equal to a times 1 plus r raised to t power. Substituting the value, we get 13,000 equal to 12,500 times 1 plus r. We leave the r as it is because we don't know what r is. T is equal to 2. Okay? Now, we need to solve for r, meaning that we need to isolate r. Here's a trick that I want to tell you. Remember the order of operation? It's PEMDAS. P-E-M-D-A-S. It stands for parentheses, exponent, multiplication, division, addition, and subtraction. So we have parentheses, exponents. These two can go together. Multiplication and division go together. Addition, subtraction also go together. So when you are just doing it, perform the operation normally, you are going in this order. Okay? Calculating. Normally. Meaning that you work with whatever number is inside the parentheses first, and then deal with the exponents, then multiplication with subtract, division, and then goes on to addition and subtraction. When you are solving for a variable or isolating a variable, this order gets changed. It's reversed. Okay? Isolating a variable. Meaning that you need to deal with subtraction and or addition first, then go on to multiplication and division, then go on to exponents, then go on to parentheses. Also, when you have, for example, subtraction, then you need to perform the opposite of that operation, which is addition for that example. If you have multiplication, you need to use the opposite operation, which is division. Okay? When you have exponent, we'll talk about it. And we have parentheses, just work with the parentheses inside. So first thing first, we need to deal with subtraction or addition. We don't have any subtraction because only subtraction here is addition here is inside the parentheses. We work with that in the last. Second operation that we have is multiplication or division. We have one here. It's multiplying by 12,500. So we need to use the opposite operation, which is dividing that by the same number. Alright? So this we get 1 plus r parentheses, and then this we can simplify this a little bit. You don't need to simplify that. You could just leave that as it is and then evaluate everything at the end. But I will simplify this a little bit. Right? These two zeros get to sort of cancel out. So that gives us 130 over 125. Now we have an exponent, all right? The next thing we need to work with is the exponent. The opposite operation of the exponent is the radical, all right? In this case, is a square root because you're squaring it, so we need to use a square root. Squaring, taking the square root on both sides of the equation. Now, here's something that I want to tell you is when you are taking the square root of a number that is being squared, when you are taking a square root of a number that is being squared, 1 plus r is being squared, and we are taking the square root of that, meaning that the result will have a positive value and a negative value. So you'll have 1 plus r equal to positive and negative radical 130 over 125. Okay? Now, we need to find out which value works. Here it comes back to the definition. Look at this. B is either equal to 1 plus r or 1 minus r. Here we have 1 plus r. Okay? And the exponential function tells you that b has to be greater than 0. You need to reject anything that is less than 0. So we need to reject negative radical 130 over 125. So reject negative 130 over 125. So that leaves us with positive 130, radical 130 over 125 equal to 1 plus r. Now we'll work with what's inside the parentheses, and inside parentheses we have addition and addition. Okay, so the opposite operation is subtraction. Subtract 1. That gives us radical 130 over 125 minus 1. All right, this 1 is outside of the radical sign, equal to r. And I will put that into the calculator. That gives us radical 130 divided by 125 minus 1. It's roughly equal to approximately 0.01. 198. Now, the question asked you by what percent, so we need to convert that into percent. And more specifically, you need to convert that to the nearest percent. Okay? So, converting that into percent, we need to move the decimal to the right of 2 places. 1 place, 2 place. That gives us 1.98%. Right? Which is roughly 2%. This 2% means that the population is increasing at a rate of 2% each year. All right, time to move on to the next problem. Example number 6. Similar problem, but we're solving for the decay rate. Okay, the population of a town, again, has started with 12,500 residents, but it's decreased by 1,000 residents this time, and after 3 years. Okay, in 3 years, it decreased by 1,000 residents. So it asks you to determine by what percent to the nearest percent does the population of the town decrease each year in these 3 years. So again, find the key information. Again, you started with 12,500. Initial value is 12,500. This information tells you that our final value is equal to A. Y is equal to 12,000 minus 1,000, because it says it's decreased by 1,000 residents. So the starting value, you have 12,500. After 3 years, it's decreased by 1,000. So you subtract 1,000. That gives us 11,500. Okay? Now this information tells you that the time is t equal to 3. We are looking for decay rate. So we need to use the decay function. That is y equal to a times 1 minus r raised to the t power. Substituting the value, we get 11,500 equal to 12,500 times 1 minus r. Again, we leave the r as it is because we are solving for it. We don't know what r is. T in this time is equal to 3. Now remember the PEMDAS. Tells us that we need to work with this again, alright? This is multiplying here. We need to do the division. Divide by 12,500. This is the first thing we need to do. Okay? That gives us 1 minus r raised to the third power equal to, again we can simplify this a little bit. That gives us 115 over 125. Okay? Now we are on to the exponent. This time we have an exponent of 3. That means the opposite operation is the cubic root. The cubic root. That gives us 1 minus r. If you have cubic root, you don't have two possible answers. That only gives you one answer. Okay? That is just the cubic root of 115 over 125. Now we're dealing with r right now. Here's what I will do. I will add r to the other side. I will add r on both sides. That gives us cubic root of 115 over 125 plus r equal to 1. Now I will subtract the cubic root of 115 over 125 on both sides. That gives us r is equal to 1 minus the cubic root of 115 over 125. That will give us, let me put that into the calculator, 1 minus the cubic root of 115 over 125, which is equal to 0.0274. Again, the problem is asking us to put that into the percent form. So we will convert that into percent, but moving the decimal point to the 2 places to the right. That gives us 2.74%, which is roughly 3%. Why do I convert to 3? It's because it asks us to round to the nearest percent. So, in this case, 3 has a different meaning. It tells us that the population is decreasing at a rate of 3% each year. All right. Now, let's go on to the last example. In this time, we're not solving for r anymore. Instead, we are solving for t. And here it comes in some interesting part. So the problem is the number of wolves in the wild in the northern section of a country starts at 80 wolves and is decreasing at a rate of 3.5% each year. How many years to the nearest year does it take for the population of wolves to drop to 15 wolves? Now let's underline some key information. First thing first, it says it starts at 80 wolves. The population starts at 80 wolves. So the initial value A is equal to 80. Now it says it's decreasing at the rate of 3.5. So R in this case is our decay rate. Equal to 3.5%. Converting that into decimal form, remember, always in the decimal form when you are using the function. That becomes 0.035. Now, it asks us how many years. We're looking for years. We're looking for time. And the unit is in year. Does it take for the population of wolves to drop to 15 wolves? Okay, so start at 20 or start at 80. After many years, we don't know how many years is that, but after that many years, it dropped to 15. Okay, it's dropped to 15. It's not drop by 15. If it's drop by 15, that means you need to do 80 minus 15. But it's drop to 15, that means the final value is 15. Right? I'll write as y equal to 15. So let's set up the function. We need to use the decay function this time. Y equal to a times 1 minus r over t, or raised to t. Okay? That is 15 equal to 80 times 1 minus 0.035. We know r this time, but we don't know t. So just leave t alone. Leave t as it is. That gives us 15, or you could work with the parentheses first. Let's solve for that first, okay? 80 times, that is, let's see, 1 minus 0.035 gives us 0.965 raised to t power. Now let's use the PAMDA. Okay, going in the opposite direction. So work with, we don't have subtraction, addition with subtraction, but we do have multiplication. And the opposite direction, opposite operation is division. So divide by 80. All right. That gives us 15 over 80 equal to 0.965 raised to t power. Now here comes the interesting part. We don't know what t is. We want to solve for t, and t is an exponent. Which function can help you solve for the exponents? It's the logarithm. Okay? Logarithm helps you find out what t equal to. For example, if you have, for example, log of 5. That tells us 10 has to raise to what power can give you 5, right? Here is the same. We want to use the logarithm to help us find out what that is. Okay? And you could do this by either, actually there are two ways. Okay? First way is you could just take log on both sides. I'll show you the two way. Method 1, that would be take a log on both sides. Any log of any base. Log of any base, it's fine. Right? Now, that becomes log of 15 over 80 equal to, here, we could move the t to the outside, okay, by the power rule. That gives us t times log of 0.965. And that what gives us log of 15 over 80 divided by log of 0.965 equal to t. Alright, that should give us, let me see, it's around 46.985, and we need to round that to the nearest year, right? It tells us here that will become 47. Method 2. Method 2 is by doing this way. So I'm going to write down what we have. Log of 15 over 80 equal to log of 0.96. Oh, no, not this. Actually, it's what is before. 15 over 80 equal to 0.965 raised to t. Okay? Here, we know that the base is this number, 0.965. Result is 15 over 80. So we can set up a fraction logarithm this way. Log of base 965 of 15 over 80 equal to t. And there is a button in the calculator that helps you to input this kind of logarithm. All right? And that should give us the same answer, which is around 47 years. So it takes 47 years for the population of wolves to drop from 80 to 15. All right? That is all.